So we're going to add on that layer of the period transformations. And we'll talk about that here in how we're going to do that. Okay. So how do we even know if there's going to be period transformations? Well, remember, yesterday we discussed the different transformations that sine or cosine could have. Okay. If we are going to have a vertical stretch or shrink, which one of those variables up there is going to have a value other than 1? So which one of those variables up there, if we're going to have a vertical stretch or shrink, which one of those variables up there will have a value that is other than 1? Which one of those variables, A, B, C, or D, identifies an amplitude change? A, that's right. A does. Okay. A does. All right. So if we see A, right, that's going to affect our amplitude, as we talked about yesterday. Okay? The numbers that are going to affect our period are going to be right in here, that bx plus c, okay, and then what's that plus d on the end going to do? Remember that? What kind of transformation does that result in? What's that plus d going to do on the end? What is it? Anytime we add something or subtract something onto the very end of our function, how does that adjust our graph? CJ? Yeah, it shifts it up or down. Vertical shift, up or down. That's right. Okay. And so with the vertical shift up or down, we'll talk about that tomorrow. We'll add that in, that little piece in tomorrow. Okay. So, alrighty. So we're going to kind of take two things at once here when we talk about our period transformations. Okay. So it's what I should say is the thing that we're going to then take into account today is this bx plus c. Both of these result in transformations of the period. How often the graph repeats. Okay, the bx plus c part. So if you see numbers in with the x, you can know that the period of your wave, how often it repeats, is going to adjust. Okay, how often your wave repeats, that's going to change. Okay, and here's how we're going to account for that. Okay, we're going to take that bx plus c, our let's do it this way. So to calculate the period adjustment, okay, we're going to take that bx plus c, whatever that happens to be inside the parentheses there, and we're going to put it between 0 and 2 pi, our normal period, right? The kind of like untransformed period. And then what we will do is solve for x. So this is a compound inequality, right? We have a left-hand side and a right-hand side. So what do we do to this left-hand side? We'll also do the right-hand side and, of course, the middle as well. We'll solve for x. And we should end up then with our new starting point less than or equal to x less than our new ending point. Okay. And that's how we're going to account for these transformations. That's how we're going to account for these transformations. So let's take a look at an example, because I think that's going to be the best way to kind of figure this stuff out. Okay. Let's graph y equals the cosine of 4x. Okay. So let me ask you this question first. From yesterday, right? Do we have any vertical stretching or shrinking happening here? Is there an amplitude change in this graph? Is there an a value other than 1? No, right? Our a value is 1, right? There's no number in front there, so we assume the a value is 1. So the amplitude is still going to be 1, which we're going to go up 1 and down 1 from the center there. But this 4, okay, that number in with the x there, that's going to adjust our period, right? Okay, that's like we have a b value here. Okay, we have a b value, okay? We're not adding or subtracting it, we're actually multiplying 4 times x here, okay? So this is actually going to result in a horizontal stretch or shrink, okay? It's going to result in a horizontal stretch or shrink. So let's take a look at this. We're going to take our, and I'll do this in red maybe so it stands out some more here. We're going to take what's in the parentheses here, and we'll put it between 0 and 2 pi. Okay? So we already said the amplitude here is going to be 1. Okay? The period, well, we'll get to that here in just a second. So we'll take that 4x, and we'll put it between our normal starting point of 0 and 2 pi. And now we're just going to solve for x. Okay. What we need to do in this inequality here to get the x by itself? What's with the x we need to get rid of? The 4. And how would you get rid of 4 times x? Divide by 4. Exactly right. So we'll divide it all by 4 here. So divide by 4, divide by 4, divide by 4. 0 divided by 4 is 0. 4 divided by 4 is 1. It cancels, right? We're left with just the x there. 2 pi divided by 4, well, that doesn't really divide evenly, but it does simplify. What does 2 pi over 4 simplify to be? 1/2 pi, or I'm just going to make it pi over 2. Yeah. The 2 and the 4 can both be divided by 2, and you're left with 1 pi over 2, or just pi over 2 there. Okay? This is now our new period. What's the length of this period? What's the length here? We start at 0, and we go to pi over 2. What's that length? What's that distance? Yeah, pi over 2, right? If it starts at 0 and goes out to pi over 2, well, it has to go at a distance of pi over 2. So our period is now pi over 2. It's going to repeat every pi over 2, not every 2 pi. Okay? It's going to repeat every pi over 2, not every 2 pi. Okay? So if we take a look, thank you, Sarah. If we take a look at this on our graphing calculators, well, actually, you know what? I'll hold off on that first. Let's graph this now. Let's graph this now. Okay? So we'll go to graph this. Okay? Since my amplitude is 1, what's the highest y value I need to show on my y-axis here? 1. Yeah, just 1. And what's the lowest y value I have to show? -1. Yep. Okay. This is the new starting point for my period. And this is the new ending point for my period. So my starting point's still at 0, so that's easy enough. I'll just put the 0 there. My ending point's not going to be at 2 pi, right? The normal ending point's at 2 pi, but we had to adjust things here. Now I'm going to end at pi over 2. So I'm just going to say, there's pi over 2. Okay? So we have the starting point and the stopping point. But what other important points do we want to find? We want to find the halfway point, right, and the quarter points as well. So we got to find those. We got to calculate those as well. Okay, we're going to find these halfway points and quarter points as well. Okay, well, halfway between 0 and pi over 2. Can anyone calculate that in their head? Pi over 4, yeah. Okay, pi over 4. Okay. Again, if you're not sure how to do that, just do 0 plus pi over 2 and then divide by 2. And that gives you pi over 4. If you want to use your calculators to help you find that midpoint, like pi over 4 there, what you can do is, like on your home screen, okay, do like the endpoints, so 0 plus 1/2. I should put that in parentheses, I guess. Okay, do 0 plus 1/2. I'm leaving the pi out just because your calculator, it's going to be hard for you to determine what the fraction is with the pi in there. So we'll just say it's 0 plus 1/2, and then divide it by 2. And there's your 0.1, or your 0.25, which is 1/4. So there's your pi over 4. And you do the same thing here. Do 0 plus 1/4, divide that by 2. Math, enter, enter. 1/8. So our halfway point here is going to be pi over 8. Right? And you can do the same thing here. 1/4 plus 1/2. Okay, because we started at 1/4 pi and then 1/2 pi. Divide that by 2. Okay, math, enter, enter. That's 3/8. So it'll be 3 pi over 8 then is your other number right here. Okay. Okay, and so now, again, you have a couple options. You can go to your graphing calculator if you want to. Type in the cosine of 4x. Okay, right? We'll go to our table then, and I'll type in pi over 8. Oh wait, 0. Sorry, first. So 0, we're at 1. Pi over 8, we're at 0. Pi over 4, we're at -1. 3 pi over 8, well, that should be 0. And then pi over 2, 1. And you'll notice that those points we picked out are still highest points, 0, and lowest points, right? And there's our graph like that. Okay? So the only extra thing we had to do here, the only extra thing that we had to do is just take that quantity there inside the parentheses, put it between 0 and 2 pi, okay? Solve for x so that you get your new starting point at any point. You're still going to then put your starting point at any point there, right? You're still going to find the midpoint and the quarter points, right? But then you should end up with the high, the 0, the low, the 0, and the high again, just like that for cosine, right? Off the axis 0, back off the axis 0, and then off the axis again. Okay. Now, you might be like, Mr. Weir, this looks exactly like the other cosine. How is this any different? Well, remember that if I wanted to graph the regular cosine here, okay, cosine, just for regular cosine, let me do this in blue maybe, just so you can compare it. Okay. Cosine of 0 would start up here as well, but then it would be all the way over here to the cosine pi over 2. Okay. Regular cosine would look something like this, and then gosh, I'd have to kind of go out. Okay. So you can see that we get like not even one full wave of cosine in. I can get half of a wave of cosine in, and it looks something. Let me see. Okay, so you can see there, like that's what cosine would look like. Okay, we would need four of these red waves to match up to get the one full cosine wave there, for it to like kind of like overlap and stuff. I'll show it to you here in the graphing calculator. It might be easier to see. There's cosine of 4x. There's cosine of x. Okay, zoom, trig. All right, so there's cosine 4x. There's cosine of x. Okay. So is this a horizontal stretch or a horizontal shrink that resulted with cosine of 4x here? Did that result in a stretch or a shrink of the cosine graph? Shrink, right? It got shrunk in there, right? Smushed in, okay? Yeah. Yeah. So it does kind of the opposite of what you'd expect, right? A 4, you'd expect, oh, it's going to make it bigger. Well, actually, no, it makes it smaller, right? It shrinks it in, okay? If you want to make your cosine graph more spread out, you would actually put like a fraction in here, like anything between 0 and 1. All right. Questions on any of this process right here? All right, let's do another one then. Let's do another one. Okay. Let's do an easier one here. I'll get it started for us. Oops, I don't think I was in black when I did this. I'll get it started for us, and then I'll have you guys finish it off. Now let me do this. I'll start mixing in things here. We'll make it y equals 2 times the sine of pi x. Okay, 2 times the sine of pi x. Okay. What is the amplitude for this graph going to be? 2. Okay. Is our period going to be adjusted at all? Is it going to be transformed at all? Yes, we have a number in with the x, right? It's not just plain x there, we have a pi x. So again, we're going to take this pi x, okay, and we'll put it down here between 0 and 2 pi, the normal period, and then we'll just solve for x to get our period length here. Okay, what should I do here to get the x by itself? What's with the x we need to get rid of? Pi. And it's pi times x, right? So to get rid of pi times x, what should I do to both sides? Divide. Yeah, divide everything by pi. And I know that's kind of weird because dividing by pi, you know, is not something we typically do. But it actually is going to be really nice when we do this. What is 0 divided by pi? 0. What's 2 pi divided by pi? What's it going to result in? 2 pi divided by pi leaves us with just what? 2. Yeah, 2. Okay, the pi's cancel. Okay. So, what is the length of our period? Just 2. Not 2 pi, just 2. Okay, so let's take a look at our graph. All right, so what's the highest y value I should put on my graph? 2. I know, I feel like the answers keep being 2. All right, and the lowest y value would be negative 2. Okay. We're starting at 0, and we're going to go out to 2. I'm just going to say here. Okay. So this is going to make it really easy to come up with those like halfway points and quarter points, right? So there's one full period, again, starting at 0, going up to 2. What's halfway between 0 and 2? We got 1, yeah. And what's halfway between 0 and 1? Our quarter point there. Our quarter of the way. What's halfway between 0 and 1? 0.5, 1/2. Okay. What's halfway between 1 and 2? Ooh, this one's a little bit different, right? Add them up. 1 plus 2 is 3. Divided by 2 is 3/2, or 1.5 if you like, but I'm going to make it the fraction 3/2. Okay. Let's go ahead and just do 2 full periods here. Why not? So 0 to 2, and then, so if my period length is 2, right, it starts at 0, goes to 2. If I want to do one more full period, what do I need to go out to? 4. Very good, yeah. And again, find the midpoint, 3, and the quarter points, 5 halves and 7 halves. Okay. Again, at this point, once you have everything labeled out there, okay, you can now go to your calculator if you want to, clear out. We'll do 2 sine of pi x. Okay, I'm typing it in there, right, just like that. Go to my table, clear out all the other junk, actually delete out the other junk. I'll just type in 0. At 0, we're at 0. Okay. Okay, and 0.5, 1/2 is at 2. So 1/2, we're at 2. And then 1, we're at 0 again. And then 1.5, which is 3 halves, we're at -2. Okay, then at 2, we're back at 0 again. Okay, and then you can just see the pattern, right? Maybe you don't even need to type in your calculator because you just know how sine should look, and that's good. Okay, I'm just going to continue the pattern there. And we'll just draw some happy little curves. Little Bob Ross. So again, there's our adjusted period, right, 0, 2. Amplitude of 2 as well. Okay. I did 2 full periods there, 2 full periods. I got one more I want to show you here. One more I want to show you. And then I'll get you guys started on your assignment. One more I'm going to show you. Okay. Okay. Cosine of x minus 2 pi. When we see a number in with the x and we're adding or subtracting that number, what transformation do we know is going to happen here? When we have a number added or subtracted to our x, right? It's in with the x. What kind of transformation does this result in? A shift. And specifically, since we're subtracting a number, we're going to be shifting which direction? To the right, 2 pi. So we're going to take our wave that normally starts at 0 and goes out to 2 pi. We're going to shift everything to the right, 2 pi units. Okay? So again, let's answer these questions, right? What's the amplitude of this graph going to be? 1. There's no number in front, so let's assume it's 1. Let's talk about the period here. Well, I got to take that x minus 2 pi. I'm going to put it down here between 0 and 2 pi. Now to solve for x here. Now to get the x by itself. Here, what do I need to do? What's with the x I need to get rid of? Well, it's not multiplied. It's not x times -2 pi. It's x minus 2 pi. So to undo subtraction, what do we have to do to both sides? Add. Yeah, I got to add 2 pi to all the sides here. So 0 plus 2 pi will become just 2 pi, and then x, and then 2 pi plus 2 pi, 4 pi. Okay. What's the length of this period, though? What's the distance from 2 pi to 4 pi? What's that distance? What's that period length? It's still 2 pi. We didn't stretch or shrink at all. How can we tell in the graph, or in the function here? Well, if you look, there's no number that we're multiplying the x with, right? There's no 2x or x, 1/2 x or anything like that. So we don't stretch or shrink our period. It's still going to be the normal 2 pi. Up here, right, we had pi times x, and that resulted in a shrink, and so our period was only 2. Right, but here the period doesn't stretch or shrink at all. It stays the same length. It just shifts, okay? And so if I want to graph this now, Okay, I still have to put 1 and negative 1. I'm no longer going to start at 0, though. I need to shift out to 2 pi. So, I don't know, I'll just say, yeah, there's 2 pi. And there's 4 pi. Okay. And again, we're going to find the midpoint. What's halfway between 2 pi and 4 pi? What's halfway between 2 pi and 4 pi? 3 pi. And then we'll also find the quarter points. So you can see, again, the only thing that's changed here is just our starting point of our period and the stopping point are shifted, right? Instead of going from 0 to 2 pi, I just shift everything right 2 pi, and so I'm starting at 2 pi and ending at 4 pi. So those are my starting points and stopping points. I still want to find the midpoint and my quarter points, though, in between. Okay, so this will be 5 pi over 2. And this will be 7 pi over 2. And again, I just find those by adding them up. 3 pi plus 4 pi, 7 pi, divided by 2, 7 pi over 2. 2 pi plus 3 pi, 5 pi, divided by 2, 5 pi over 2. Okay. And then when I go to graph, I am not going to start at 0. I'm going to start at 2 pi. And so I'll just go ahead and use my graphing calculator here too to help. I'll change this to be cosine of x minus 2 pi. Whoop, 2 pi. Okay, there. Second graph. Delete out this old junk here. 2 pi gives me 1. 5 pi over 2 gives me 0. 3 pi gives me negative 1. 7 pi over 2, that's going to be 0. And then 4 pi gives me 1. And then connect the dots. And of course, we know it continues on in both directions there. Okay, that's it. Okay, that's it. That's doing the horizontal transformation. Okay, questions on any of that? Questions on any of that? All right.
Is it gonna be on?
I'll be posting it. Yes. Yep. To YouTube. Yes. All right. So, again, I'm going to give you guys an assignment out of the green book. We're going to be back on page 912. So I'm going to repost that same PDF there. Okay, but we're just going to adjust. Excuse me. We're going to adjust the. We're going to adjust what numbers you're going to do. Okay, so let's see here. Which ones do I want you to do? I'll have you do number number 6. Number 11 might be too much. I want to do that. 2. How about 18? Okay, so we'll do 6 and 18 from that section of pages. And then I'll also have you start on page 9. Page 919. And we'll do more on page 919 from the green book as well. I'll have to rescan that one. Page 919, I'll have you do number 919 number 4. And oh, darn, I don't want it to be x plus 5. Darn. Well, you know what? No, I'll be okay with that. I think it should be okay. 4 graphs. Okay, 4 graphs we're going to do. All right, and I'll scan the second set of pages there because I didn't do that yet.